My name is Mama Arif Daniel Berizwan. I'm going to present introduction. Couple and moment of force are important in mechanics for understanding rotational behavior. The moment of the force measures the turning effect of a force and is different from mechanical work. Free body diagrams help visualize and analyze force acting on object. The centroid represents the geometric center of an object and it is used in studying distributed force. The moment of inertia measures an object resistance to change in rotational speed and determines the force required to alter its rotation.
In this project, students need to find four different types of civil engineering structure. Students required to introduce and analyze the photo, material, location, type, and others each of the structure used in the project. Additionally, for each structure, students must draw a free body diagram plus they must calculate the laws or forces that have been applied to the structure and explain its center of gravity and moment of inertia.
Okay, the objective of this project is to determine the construction material and the purpose of each used structure, learn to create free body diagram for a variety of structure, gain the capacity to calculate the action or loading applied to a structure, express a knowledge of support reaction, become a proficient at located and centroid or center of structure, and lastly describe the idea of a moment of inertia and the related to construction.
This structure is a roof structure. Roof is an important part of any civil structure, providing shelter, protection, and structural support. It serves as the uppermost covering that includes a building protecting it from the environmental elements such as rain, snow, wind, and sunlight. The design and construction of a roof require careful consideration of factors such as structural stability, weather resistance, aesthetic appeal, and functionality. Roofs are designed to bear the load of its own weight as well as any additional load, such as snow accumulation or maintenance activities. The selection of roofing material depends on various factors, including the climate, local building codes, budget constraints, and architectural style. This material used to build these roofs are concrete or clay tile. And the structure we are gonna work on is this upper roof structure located near THM, near UTM Healthcare located. This is the free body diagram of the roof structure we're gonna work on it. The support reaction for this roof structure is a roller support. We estimated the loads at 500 Newton. So we calculated the loads and the loads for Y is 1250 Newton. And we also estimated the actions at same result is 1250 Newton. We're gonna start the calculation for the centroid. We divided the structure into two parts, A and B, and we take the height as we estimated the height at 9 meter, and the base is also 9 meter. This is the calculations for the centroid area of the structure. We calculated the area x and y. So the result for x is 1.5 meter, and the result for y is 3 meter. This is the calculation for the moment of inertia at x-axis and y-axis. So we calculated both of them. Result for x-axis is 182.25 meter power 4 and y-axis the result is 45.56 meter power 4. In conclusion, the calculated centroid moment of inertia and total area provided vital details about the structure's behavior under vital loads. These numbers indicate that the construction will be more resistant to bending around the x-axis than y-axis. These values should thus be considered while designing the support or analyzing the behavior of the structure under different loads.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abu Hanifah bin Muhammad and my metric number is DF 220149. And this is my turn to explain about the beam. Okay, firstly, the beam, as an engineer, uh, who need a knowledgeable with a beam structure, because the beam uh, are a crucial class of a structure element. The integrity of a building foundation depend on this construction, which is crucial for a wage transfer. Construction made of beam that overhang. The most common type of beam uh, are used in construction, especially is a continuous, fixed, truss, and simply supported by remaining rigid under the load pressure. This beam support the weight. The beam obstruct the force and it applied laterally to the axis. Beams are frequently used in construction to support column, which encourage an ideal distribution of bending stress inside the beam and less bending in the column. The need length and width of the beam are determined by the weight imparted to the beam. The maintaining the proper distance between them. An understanding of a beam dimension can be gained by calculating the internal force operating on it. As a result, I use a fixed beam in my report. Because there are more support reaction, then there will be equilibrium equation, because a fit beam is supported by two fixed support at each end. The strength of a fixed beam is effectively distributed along its whole length. The support, however, are subject to a bending moment that can necessitate strengthening. Consequently, when fixed to the end support, a lighter beam can use for a given load. So this is the actual structure. So I will explain about the detail of the structure. And the firstly is the location of the structure is at Pekan Kelaban section 2 at Melaka Tengah, Melaka Bandaraya Bersejarah. The material of the beam is concrete, and then the type of fixed beam that I chose to put in the report is a fixed beam. So this is the free body diagram for the fixed beam. The fixed beam is supported by two fixed support at each end, left and right. So this is the estimation of action, load and loading. So the calculation, we assume the calculation, the value of the calculation. Firstly, the mass of load is 23 kilonewton per meter. The length of a beam is 4 meter. A magnitude of a beam is 23 kilonewton per meter plus 4 equal to 92 kilonewton. So the point load of 92 kilonewton rests in the center of a beam that is simply supported. For the support reaction of the beam, summation of Fy equal to Ay plus By equal to 92 kilonewton. Summation of Ma equal to By multiply 4 minus 92 multiply 2 equal to 0. By equal to 92 multiply 2 divide 4 equal to 46. So Ay equal to 46 kilonewton. For a centroid of the structure is they have two part. The part one is area 4 multiply 0.4 equal to 1.6. So the summation is 1.6 x 4 divided 2 equal to 2, y 0.4 divided 2 equal to 0.2. AX 1.6 multiply 2 equal to 0.2. So the summation is 3.2. AY 1 for the AY 1.6 multiply 0.2 equal to 0.32. So the summation is 0.32. So the moment of inertia of the beam, the moment of inertia about x-axis, ISS equal to IS plus AD cube. So we have the part one is the area, 4 plus 0.4 equal to 1.6. IS equal to BH square, BH cube per 1 2, that we get 4 multiply 0.4 cube per 1 2 equal to 0.021. Then the other one is 0 and 0. So the summation of the area is 1.6. So the moment of inertia by y axis Iyy equal to Iy plus as cube, as square. The part one is area, 4 multiply 0.4 equal to 1.6. For the Iy equal to b cube h per 1 2, that we get 4 cube 0.4 equal per 1 2 equal 2.13, and then s equal to 0, as square equal to 0. So the summation of the area is 1.6.
Hi, my name is Muhammad Arif Daniel bin Rizwan. My metric number is 220090. I'm going to present about dam. I have typed dam Tasik Kenyir. I'm just take a picture from Google. I also draw a free body diagram and estimation of actions or loadings. At estimation and loading, it have 20 kilonewton per meter. The next part is support reacting acting on the structure. Ay is equal to negative By, so we get the Ay is negative 1.00.67 kilonewton meter. The next one is centroid of dam. I have calculated the area and Ax and Ay, so I sum it and divide the average Ax with average area. And this is same with Ay. So I get the X is 32 meter and Y is 65 meter. The last is to find the moment inertia x-axis and y-axis. We get the final answer for x is 22.789 to the power of 6 meter to the power of 4, where the y is 3.963 times 10 to the power of 6 meter to the power of 4.
Okay, the structure that I choose is a bridge. Okay, as we can see here, bridge is structure that connect one point to the one point. We can say that bridge is a structure that across a river to connect the that area to the other area. Okay, we can see free body diagram of the bridge in there. Okay, centroid of structure. First, we must find the area, and next we must find the center of the structure. Okay, after we find two of that, we can finally get an answer of centroid of structure. Okay, for the moment of inertia for y and x axis first, we must find the area, and we just put all the number into a formula that shown like for x is ix equal to bh square over 12, and for y is iy equal to b square h over 12, and after that we can get the answer.